Chapter 4, review number 37b, it says show that the function satisfies the mean value theorem on the interval, and then find the value or values of c in which it occurs. So how do I know it satisfies mean value theorem? Has to be continuous and differentiable. So if you look at the graph of x times natural log of x, it's going to be smooth, it's going to be continuous, and so it's differentiable in that interval. So it does satisfy it. Part B is what I asked, find the value or values in that interval that satisfy it. So if that's the case, then there has to be at least one c value where f prime of c is equal to f of b minus f of a over b minus a. So the instantaneous derivative has to equal the average derivative in that interval. Derivative. Okay, so find the derivative, f prime, product rule, so x times derivative of natural log plus 1 times natural log. Okay, so our derivative is 1 plus natural log of x. And our average derivative is literally just the slope between these 2 points. You're going to have from x value of 0.5 to 3. So in algebra, you'd be asked to find the slope between 2 points. In this case, it would be 0.5 comma f of 0.5, which is 0.5 times natural log of 0.5. And your other ordered pair is 3 comma f of 3. So you subtract the y's and you subtract the x's, and you have the slope between those 2 points. Alright, so f of b, so f of 3 is 3 natural log of 3 minus f of a 0.5 natural log of 0.5 over b minus a. That's a point. It's 3 minus 0.5. Alright, so we can figure out approximation here. So 3 natural log 3 minus 0.5 natural log 0.5, that's our top, and then divided by 3 minus 0.5. So our average rate of change, our slope between the 2 ordered pairs, is 1.45696. Okay. And that has to equal the derivative somewhere. Here's our derivative. So 1 plus natural log of x equals 1.45696. So I still have that stored in my calculator. I'm just going to subtract 1. So then I have natural log of x equals 0.45696. And then e to the power, so x is e to that. So I'm going to go e to the answer, and we have 1.579. That's our c. Our c is 1.579. So that tells me that it occurs, if I wanted to look at the graph of it just to show what just happened. Graph, this blue is the graph x times the natural log of x. See that it's continuous, smooth, differentiable, so it meets the mean value theorem. The red one is my 2 ordered pairs, 0.5 comma f of 0.5 and 3 comma f of 3, and I connected them with this line. So there has to be a point somewhere on the interval where the derivative, the instantaneous derivative, has to be parallel to that. So it looks like it happens like right here, if you can imagine. I don't know, it's hard to tell. There's my slope that is parallel to that one, and that happens at 1.579 is where that occurs.